Hello everybody. In this video I will talk to you about chapter 10.2 in our textbook, which is talking about test for independence. So before we start talking about actual problems, let's do a little bit of terminology and what we're really trying to figure it out here. We will talk about contingency tables. Those are tables that relate to categorical variables. And in this example, you see that, okay, I have some majors for students and also hours of studying per week. So we want to ask this question, majors and number of studying per week, number of hours of studying per week, are they associated with each other? Is one independent on another? Okay, and that's basically the essence of this entire section. So we have row variables. In this case, it's from 0 to 10, 11 to 20, and more than 20 hours per week. And then column variables are the majors, and we want to establish if there is an independence here. Okay, so each cell has a number. So let's say 103, that represents number of students whose major is social science and they study anywhere between 11 and 20 hours per week. Okay, the grand total is the entire number of all these students that took the survey. So a lot of times it will be given to you. In this case, it's not. So to find that number, you would actually just add up all of the cells in here. Okay. All right, let's talk a little bit about how we do computations here and what's the problem. How do we set up the problem? Okay, so the first step is to state the null hypothesis and the alternative hypothesis in the context of the problem. So here you have the general statement. The two variables are independent, the two variables are not independent. This will never change, okay? So the null hypothesis will always say that the two variables are independent. But what does it mean in the context of the problem? So if we go back to this problem here, you would say that majors and number of hours studying per week are independent of each other, okay? You would actually use the variables that are provided to you in the problem. And then for the alternative hypothesis, you would have said major and the number of hours studying per week are not independent. There is a relationship here. Okay, then computing the expected frequencies, right? So these numbers right here, they're observed. This is what we've collected. We want to compare these to the expected values for each one of these cells. And then how do we compute it? We would take the total for the row multiplied by the total for the column and then divide that number by the grand total. Okay, now this is a lot of computation and it can be a little bit tedious, but the great news is you can do all of that on a calculator. The calculator will do all of that stuff for you in one step. Okay, once we compute those frequencies, we need to make sure that every one of them is 5 or bigger. Otherwise, we cannot conduct the hypothesis testing. Okay, let's take a look at what we do then. We identify the significance level alpha. Then, just like in section 10.1, we compute these values right here. Observed minus expected, square that, divide by expected, and then we sum it all up, okay? And that's going to be your chi-square value that we're looking for, okay? Again, it could be very tedious if you were to do it by hand, but the great news is both TI-83 and 84 calculators have a command that does that for you, okay? So you actually don't need to do this by hand. Then we'll look for the critical value in table A4. Using R-1, C-1 degrees of freedom, where R is the number of rows, C is the number of columns. We compare this to the test statistics, the one that we've computed. Okay, that's your setup, how you do this, how you solve these type of problems on your calculator. And the next slide tells you all about how to do it with a calculator. So if you guys would like to get the slide, I actually posted this on Blackboard. This entire presentation is posted in chapter 10 folder. So I'm not going to read this for you, but I'm just going to go ahead and do a problem. and then you will see that it's actually kind of fun and not so difficult. So let's take a look at this problem right here. What do we have? We have 4 different brands of cucumber seeds. Okay, and we've taken some samples, and after 14 days of planting, some of them germinated and others did not. Okay, so we have this data right here. We would like to see if there is a relationship between brands of these seeds and the rate of germination. Okay, maybe one brand has a higher rate of germination than the other, so if you were interested in planting cucumbers, then you would probably go with that one, right? Okay, so let's go ahead and see how we would solve this problem. Okay, so I have the problem in front of me. The first step is to write out my hypothesis. Okay, so my null hypothesis would say the brands of cucumber seeds and the germination rates are independent. Okay, there is no relationship between those two. And then the alternative hypothesis would say same thing, right? But they are not independent. Okay, so one or two, or maybe all of them just produce completely different rates of germination. All right, so in the context of the problem, we'll write those hypotheses. What do we do next? Okay, well, I should compute the expected values for my for each of the categories, right? So the expected values table for each category of germination rate and each brand. So let me go ahead and show you how you would do this by hand. Okay, so here's your brand A, B, C, D, and then this one germinated, this one did not. Right? So here's your expected value table. How do we do it? So if you were to do it by hand, what would you have to do for each one of these cells? You would have to find the grand total. Okay, well, what is the grand total? I already computed it. So the total for the sample is 177 seeds. Okay, so let's say for brand A, what would I have to do? I would have to do the total for the row or for the column times the total for the row, okay, and then divide that by the grand total. So let me go ahead and do one computation here. So what would I do? Okay, so I'd say for A, I would say my grand total is 50 times 139 and divide by 177. So in this case, the table doesn't give you the totals for each of the column and the rows, so you can actually compute them. So how much would that be? Once I compute it, I get approximately 39.27. Okay, so that's the number that's gonna go in here. Then let's go ahead and do the same thing for germinated brand B. I would have to do the total for this column times the total for the row 1 divided by the grand total. So this one would be, let's see, what is this one? 42 times 139 over 177. That gives us about 32.98. So that's the number that's going to go here. Okay, now if you take a look at these closely, so 40 was observed value, 39.27 is expected, so it's actually pretty good, right? You say, well, that's really close. Here 33 and 32.98, which is really 33, so these values kind of match up, right? And if you were to do it by hand, you would actually have to do 6 more computations, but the good news, you can do all of that on a calculator. Okay, now there is a point here that I'm trying to make. When you guys compute these values, these expected values, so these are your expected values, right? So these are your expected values. They need to be relatively close to the original observed values. Okay, so they cannot be, if you have 40 here, if you have a number here that says something like 0.42 or 0.13, some very small decimal, something must have gone wrong. Okay, make sure you recompute those correctly, and I see that mistake all the time. They shouldn't be very different. Okay, so what do we do now? Okay, now we need to see how do we do this computation on a calculator, because this will take you too long to do it, right? Let me go ahead and pull out my calculator. Okay, so turn it on. Okay, we do this with a matrix. You're gonna go to second matrix, and we're going to scroll to edit. Okay, and we'll select matrix 1, and it's going to ask you for the size. The size goes rows by columns. So mine is already set up to save some time. I already plugged those numbers in. We have 2 rows, 4 columns, and you plug in your values for each of the cell, right? So you plug the numbers in here. Okay, so here you have all of the numbers from this table. Now we're going to go second quit. And that's going to clear the screen. And now what we're going to do, we're going to do one of the tests. So go to test. My calculator is not really working today. Okay, test. We're going to go to test over here. And if you scroll down, one of the commands is chi-square test. Okay, so for TI-83 calculator, it's chi-square test command C. We're going to pick this one right here. By default, the matrices that will be there, A and B, you can actually change that, but if that's the only thing that you do, then you don't change that, right? So let's do observed is A. For expected B, you do not need to compute it. The calculator is going to compute that part for you. Okay, so what we're going to do now, we're going to go ahead and press calculate, and we get chi-square of our data. That's computed for us. Okay, let me see. Oop. Okay, so chi-squared is, oh come on, don't keep disappearing, 11.265. That's our value, right? So that's what we've computed. So here's your chi-squared. Chi-squared is 11.265. Okay, now let me show you something real quick. Let me bring this calculator back. If I'm going to go second matrix, second matrix, and now look, in matrix B you have something in it. Something was put in it by the calculator. So if you press 2 and press enter, all of the values that we could have computed by hand, these values right here, the ones below the table, are already in it. Okay, so just take a look. See, these are all the computed values, and they match up to what we have, the first 2, right? We computed for germinated A and B. So that's why you don't need to do any of it by hand. Now you inspect this, make sure that all of them are greater than 5 or bigger, and they are. And the smallest value here is what, 7.94. But that's how you do this on a calculator. You don't need to do any of this by hand. Now, are we done yet? Okay, we're actually not quite done, right? So we've computed this value. So now what? We need to compare this to the table value. Okay, so how do we do that? Well, let me go ahead and copy this here. So computed value, computed chi-squared is 11.265. What about table value? That one we need to find. Okay, so what do we need? We need alpha, and that's 0.05. We need degrees of freedom. Okay, what is degrees of freedom? Number of rows, 2, minus 1, times number of columns, 4 in this case, minus 1. So 2 minus 1 is 1, 4 minus 1 is 3, 1 times 3 is 3. So that's our number for degrees of freedom. Now I'll go back to my table here, and I'm looking for 3 degrees of freedom right here. Alpha level is 0.05, so the number is 7.815. Okay, 7.815. 7.815. Okay, so let's see what the conclusion is. What does it mean? If I have my chi-square distribution that looks like this, okay, 7.815, that's my cutoff value, right? So 7.815. Everything to the right of this will be unusual, right? So this is where, if the data falls in here, then we say this is unusual. So where's 11.265? Let's say it's somewhere here. 11.265. That's our computed value, right? 265. Okay, what does it mean? It means that we reject the null hypothesis, right? So chi-squared of the data that we've computed is greater than chi-square from the table that's given to us, right? That means we reject the null hypothesis. There is sufficient evidence to support the claim that the rate of germination and the seed brand are not independent, right? There's some sort of relationship there, are not independent. Okay, we rejected the null. Let me go ahead and go back up here. Let's see. The null hypothesis says they are independent. Okay, we rejected it. We said no. One of the brands, and maybe some of them, maybe more than one, have different germination rates. Okay, so this is a little bit different, right? So it's a little bit counterintuitive because you're so used to saying p-value is greater than alpha level, then we fail to reject. But here, we're no longer going to talk about p-value. We actually talk about the critical value for each of the problem. Okay, so that is one of your examples for test for independence. Okay, so let me run down through this again real quick. First step, set up the null alternative hypothesis in the context of the problem. Okay, then we plug in these values right here in your matrix, where matrix goes rows by columns. Okay, be very careful when you plug those in, because just one number that's different can make your answer completely wrong. Okay, then we run the test. We compute the expected values here. Okay, you can do this on a calculator real quick. You find your chi-square value, the one that you've computed. You look at the table to find the table value. Okay, on the test, I'm just gonna give it to you. Okay, on the test, this will be given, so don't worry about bringing the table or anything like that. Okay, and then we compare those two, make the conclusion in the context of the problem. Okay, please don't just say, okay, the variables are independent or not independent. Actually tell me what variables we're using. Okay, so in this case, it's the rate of germination and the brand of the cucumber seed. And we concluded they're not independent. Okay? All right, well, thank you for watching. And if you need these slides, again, they are on Blackboard, so feel free to download them and use them. Okay? All right, thanks again.